Hi students, in this class we are going to study the inductance of composite conductors. First of all, let me explain what is meant by composite conductor. In the transmission lines, we do not use a single straight wire for the conductor, but we use strands of wires twisted together to form a single conductor, which will give more tensile strength. Usually we use aluminium or alloys of aluminium for the conductor, because aluminium is lighter in weight and cheaper in cost when compared to copper conductors. Now these are some of the examples of composite conductors, because in each conductor we have number of strands. You look at the first conductor, ACSR conductor, we call it aluminium conductor, steel reinforced. At the center you can see a color difference. These are the steel conductors. So there is some steel reinforcement. And the second one is all aluminium conductor. Here we do not have any steel reinforcement. Now we look at this water sprinkler system. When you consider this area is watered by this particular sprinkler, but obviously we get water from the neighboring sprinklers also. This sprinkler will also give certain water droplets to that particular area. So in this area we get water from that particular water sprinkler. Then from the neighboring sprinkler also we get water droplets. This is quite analogous to the magnetic flux lines. We have three conductors. The magnetic flux lines produced by the conductor A is this one. In the conductor A, we will have certain magnetic flux lines due to the conductor B. From the conductor C also we get certain magnetic flux lines. So in the conductor A, we get magnetic flux lines due to its own current, plus certain flux lines from the conductor B, plus certain flux lines from the conductor C. So the total flux linkage on the conductor A will be psi A is equal to 2 into 10 raised to minus 7, the current flowing through that conductor IA into logarithm to the base E. Log E can also be represented as natural logarithm ln, both are same. 1 by R dash plus the flux linkage due to the second conductor, 2 into 10 raised to minus 7, current is IB, log the distance is D12, plus the flux linkage from the third conductor, 2 into 10 raised to minus 7, the current is IC, log 1 by the distance is D13. This is the total flux linkage on the conductor A. Now we'll see a couple of formulas used with the logarithm. So you know, log x plus log y can be written as log xy, and minus log 1 by d can be written as log d. Then 1 by x log d can be written as log xth root of d. So these formulas will be useful while deriving the inductance of composite conductors. Now we consider two composite conductors, A and B. We call it composite conductor because in each conductor we have number of strands. In the conductor conductor A we have 1, 2, 3 etc. up to X number of strands. And in the conductor B we have Y number of strands. Current in the first conductor is I, and that in the second conductor is minus I because it is the return path. Here the distance among the strands can be written as so this distance can be d12 and this distance can be written as d11 dash. Likewise, you can find out the distance between any two strands. Now let's find out the flux linkage on the strand number 1 because we are going to find out the total inductance. Inductance equals flux linkage per current. So we should know what is the flux linkage in each strand. So flux linkage on the strand number 1 is equal to 2 into 10 raised to minus 7 into what is the current flowing through the strand number 1? It is equal to I by X. We have total current of I amperes in the conductor B. We have X number of strands. So current through each strand equals I by X into log 1 by R dash plus what is the flux linkage from the second strand? Log E 1 by D12 plus etc. up to log 1 by D1X because we have X number of strands in the conductor A. What is the flux linkage from the second conductor? 2 into 10 raised to minus 7. The current in each strand will be minus I by Y. The total current is minus I ampere. We have Y number of strands there. So the current through each strand will be minus I by Y into log. Here the distances are 1 by D11 dash plus 1 by D12 dash plus etc. up to 1 by D1Y because we have Y number of strands in the conductor B. This can be written as 2 into 10 raised to minus 7 I by X log, it is in the form of log X plus log Y, which is equal to log XY. That is log 1 by R dash into D12 etc. up to D1X plus 2 into 10 raised to minus 7 I by Y. That minus log 1 by D can be written as log D. So it becomes log D11 dash, D12 dash, etc. up to D1Y. This is equal to 2 into 10 raised to minus 7 I into 1 by X log D can be written as log xth root of D. So it becomes log polar logarithm with the base E This is equal to y-th root of the numerator is d11 dash, d12 dash, etc. up to d1y divided by denominator is x-th root of r dash, d12, etc. up to d1x. This is our flux linkage on the strand number 1. What is the inductance of the strand number 1? L1 is equal to the flux linkage per current. What is the current flowing through the first strand? It is I by x. So this can be written as 2 into 10 raised to minus 7 into this currents will be getting cancelled. This current and this currents will be getting cancelled. X into this R dash can be written as R dash is equal to, it can be written as d11. It is a self distance. So it can be written as d11. It's also equal to d22. It's equal to d33, etc. This 2 into 10 raised to minus 7 x into log y-th root of d11 dash, d12 dash, etc. up to d1y divided by x-th root of, what is r dash? It can be written as d11, d12, etc. up to d1x. This is a inductance of the first strand. Similarly, you can find out the inductance of second strand. So this is equal to 2 into 10 raised to minus 7 into x into, what are the distances for the second strand? This is, instead of 1 you can write 2 when it comes to the second strand. So it is d21 dash, d22 dash, etc. up to d2y divided by x-th root of d21, d22, d2x. Now if you look at the inductances, these strands have different inductances. Now let's find out the average inductance of each strand. Average inductance equals L1 plus L2 plus etc. up to Lx divided by x. So we assume that this is the average inductance of each strand. So this will be equal to L1, this will be equal to L2. This is our assumption. Now what will be the total inductance of the conductor A? We have x number of strands. We have x number of strands in the conductor A. We have x number of strands in conductor A which are electrically parallel. So LA will be equal to, what is the average inductance of each strand? L1 plus L2 etc. up to Lx by X. So the inductance, the total inductance of conductor A will be equal to L average by X, because we have X number of strands in the conductor A. So this is equal to L1 plus L2 plus Lx divided by, it becomes X square. We already have X here. X into X, it is equal to X square. So LA equals 2 into 10 raised to minus 7 into log this 1 by X will be cancelled with this X. So we get 1x in the denominator. We already have a y in this root and x in this root. So this x also comes here, so it becomes xy and this term becomes x square. Now what are the terms for inductance 1, L1? The denominator, it is d2 dash, d2 dash, etc. up to d2y. The denominator term for the inductance 1 is these terms are d1 dash, d1 dash, etc. up to d1y. What is the denominator term? It is d11, d12, etc. up to d1y. These are the terms for the inductance L1. Then what are the terms for inductance 2? It is d21 dash, d22 dash, etc. up to d2y. And the denominator, it is d22, d21, d22, etc. up to d2x. And this term is x into etc. up to the last term will be dx1 dash, dx2 dash, etc. up to dxy. And the denominator, the last term will be dx1, dx2, etc. up to dxx. The terms in the numerator are the mutual distances, and the terms in the denominator are the self distances. So we can write this expression as 2 into 10 raised to minus 7 into logarithm to the base e dm divided by dsa. Dm is the mutual distance and dsa is the self distance of the conductor A. Dm is GMD, geometrical mean distance. It is geometrical mean distance, and the DSI is called GMR. It is the geometrical mean radians. Suppose the two conductors are identical. If the two conductors are identical, then dSA will be equal to dSB. Then LB can be written as 2 into 10 raised to minus 7 into logarithm to the base E dm divided by ds. So LA is equal to 2 into 10 raised to minus 7 into logarithm to the base E dm divided by ds. As you know, its unit is Henry per meter. Usually the unit of inductance is Henry, but here we considered the conductor of length 1 meter. So its unit will be Henry per meter. What is the total inductance or the loop inductance? L is equal to LA plus LB, which can be written as 4 into 10 raised to minus 7 logarithm to the base E dm divided by ds, when its unit is Henry per meter. This is the total inductance of the composite conductors in the single phase system.